Any questions? Seems like we last left off, we had done the few boxes on the wedge, and we had just solved for the angle, so it's in equilibrium. Or did we get that far? What was the last thing we did?
The last thing we did was solve for the angle.
Okay, we did actually solve for it?
Yes.
And what was, this was 37
Yes.
degrees. Box A, what was the mass of box A?
3 kilograms,
And box B?
5 kilograms,
And what do we find this angle to be?
28.7 degrees.
28.7?
Yes.
Alright. So let's change the problem around a little bit. I think I asked, are there any questions? If I did, are there any questions? All right, so now I'm going to double this angle. Still no friction. So if I double that angle, makes it steeper. So that's still, I'm pretending 37 degrees. This one will be 57.4 degrees. What is the acceleration of the masses? We're going to go through the exact same process that we did before. The force diagram doesn't change at all, or force diagrams. So on A, we had weight going down, A. We had normal force going perpendicular and away from the ramp, and we had tension going up the ramp. And then for B, we had weight going down, weight sub A, Y sub A, weight going down, normal force perpendicular to the ramp, and tension acting up the ramp, B. And that should have been what we had before. Without friction, it's just as simple as that. So again, going through the process. So we did the force diagram. What is the direction of acceleration? Because remember, in the first case, there was no friction, but we were trying to find that second angle, this angle right here, so that they would be in equilibrium. So, what's going to happen now? Will it accelerate?
Yes.
Okay. Why do you think that?
Because the angle's twice as steep.
Yeah, pretty much. I mean, the 28.7 degrees was that angle so that it would not accelerate, so any other angle there would make it accelerate. So it will accelerate. Which way do you think it will accelerate? Or which way do you think B is going to accelerate?
Down.
An A?
Oh.
All right. So we have acceleration in this direction. and acceleration in that direction. It is an ideal rope, so they will accelerate at the same magnitude. Because B is going to move the exact same amount of distance that A will move. We assume the rope will not break. So that's the acceleration there. Now, if you acknowledge that that's the acceleration, and then you guess the wrong direction that it will accelerate, that's okay. It's just a matter of interpreting what we get in the final answer. But now, the coordinate axes. I want to have one axis in the direction of acceleration and one perpendicular to that. So I'm going to have an I hat j hat for B and I hat j hat for A. For whatever childhood scars there are, I'm going to make the direction of acceleration I hat, I sub B, and J sub B. Now, if you wanted J sub B to go in the other direction, the opposite direction of what I wrote down there, that is perfectly fine. There's absolutely no problem in that. For this one right here, I hat sub A, and what the heck, let's do J hat sub A. Now we get back to, now that we've set up the coordinate system, we're at the decomposition phase. In other words, break a vector up into its components. Which vectors do we need to break up?
The weights.
All right, now we have done that. I'm just going to label this theta sub A and theta sub B. So this one right here, when we break it up, down the ramp is going to be W sub A sine of theta A. And then we have our tension, normal force, and into the ramp will be W sub A times the cosine of theta A. And for B, do the similar thing. So I have Y sub B, tension, and then the weight break up W sub B cosine of theta sub B, and down the ramp, W sub B sine of theta sub B. Now I sort of zipped through that bit because 2 days ago we spent a bit more time on it. But if you recognize, if I'm given the horizontal angle, or the, probably better wording, if I'm given the angle with respect to the horizontal, then sine of theta is going to be down the ramp, cosine theta is going to be into the ramp. And unless it's explicitly stated, do not assume that that top angle is 90 degrees. I might draw it like it looks like 90 degrees, but it is not 90 degrees. All right, decomposition done? All right. Now time to hear your angelic voices. First off, how many equations of motion will there be? 4. All right. So we're going to have one for I hat A, J hat A, I hat B, J hat B. All right. An angelic voice, sing it out.
I hat A would be force and tension minus W sub A sine theta A equals M A.
Like that?
Yes.
All right. Someone, not Ethan, tell me what's wrong with this equation. And as a hint, I don't have to erase anything.
The arrow over the.
No, because that A right there is the magnitude, and it's in that direction, so I don't have to put the arrow over the A. Now, I suspect that if Ethan kept going, he would correct the mistake, but there is an issue just straight up with what's written right here. I think, Ethan, you will have that look of, you realize what your mistake was?
I had sub A at the end.
No, we've already identified it all as I had sub A. If you want to throw that in there, then it gets thrown on to each term. Well, why don't you keep going, then we'll come back to this. At least you look like you
Would
were
it
about
be-
to say something brilliant.
Acceleration survey?
No, it's still, both boxes will move it with the exact same acceleration, so that's why I use the same A for them. All right, let's move on, we'll come back to it. Someone other than Ethan, give it a shot. Tell me another equation of motion. The worst that happens is that you're wrong. Right there. Yeah, there's a little bit of us on there too, so.
That's better.
Even though there's a little bit of a distraction there, I have not forgotten the question that I asked.
Y sub A.
So which one are you doing? Oh, this one?
Yeah.
All right, so Y sub A,
Minus W sub A cosine theta sub A equals mass times 0.
all right. Going with what he has, what's written right there, you would not run into any problems. But let's be picky right now. There are two issues with what he has with this. Ethan?
It'd be negative 1A plus,
And why is that?
because of the direction that we chose to have
Yeah.
sub A go.
I set towards the ramp over here to be positive for no particular reason. If Jay had in the other direction, then only one mistake, and you have the same mistake that Ethan had. But let's move on to the next ones. We'll correct it before we get past this stage. All right. The B equations, new voice.
WV sine B theta minus.
WB sine theta B? Is that what you said?
Yes. Oh wait. Yeah, it is sine theta B, sorry. And then minus F sub T equals MA.
What are the issues with this? If we leave it like this, if you left it like this, there would be an issue in the final answer. Right. One mistake is the same one that Ethan and Luis made. The other mistake is the same one that Luis made.
Be plus 4.
Sorry?
Would it be plus force of tension?
And I set up the coordinate system. Oh, I apologize. That was my own issue. So what happens when I don't pay attention to the coordinate system? No, the mistake you made is the same one that Ethan and Luis made, but, I was thinking that was backwards, but that was my silliness. All right. Everyone spotted the issue that all three of them have made? All right, let's go on to the next one. Last equation. A new voice. Let's see if we can, if the fourth person will make the exact same mistake the other two made. The other three made. Again, the worst thing that happens is you make a mistake. And I'd like to think that the mistake I had just made sort of models the fact that it's okay. What would the frizz say? Does frizzle?
Oh.
Come on. Surely someone in here has watched Magic School Bus. And what does Miss Frizzle say?
We're gonna take a field trip?
Yeah.
Yeah, besides that one.
Okay.
In reference to taking a chance.
Fasten your seatbelts.
Take chances, make mistakes, get messy.
Don't put on these.
Did they wear seatbelts?
I don't know, man.
This is a school bus.
All right. So anyway, the last equation.
I don't think this is right, but I'm
Go for
gonna
it
try it
anyway.
anyways. Would it be, WB cosine? And then, minus, the force speed
Which, minus what?
minus, I forgot what I was looking. The force with the T, I can never remember what it stands for.
The force, this right here?
Yeah,
That's a Y.
oh, okay, then Y equals M parentheses 0.
All right. This is what I heard you say.
That's
there-
what I'm looking at, yeah,
What about
Okay.
cosine theta?
okay, yeah,
All right, so what theta is this?
Theta b.
All right. And which Y is this?
YB,
So now we have only the issue that the other three had. So all four of you made the exact same thing. Congratulations, that seems to be, going around. Is that a raised hand because you realized
Do
there's an
we
issue?
not need the subscript because we already have the written in the thingy thing?
Wait, do we not need the subscript?
I mean, I don't know. We
But-
have I subscript. I had subscript A. Do we need A in the equation? The subscript.
Oh. Where are you thinking we need to have I hat written in here?
No, I'm saying we have A in the I hat. Do we need the
Oh,
subscript
oh,
A?
Yes, we do, because this is right here is just sort of a guideline so that I make sure we get all the equations. But once we get past the equation step, this stuff is, we ignore this completely, so we need to be able to differentiate. Which is at the core of the issue that all four of them had.
Oh, the masses. They're
Thank
different
you.
masses.
That mass and that mass are different from those masses. That's the mistake. There is one other issue with what Brewer did based upon the convention that I set up. Again, same thing that Luis did. If you just stuck with this, there is not anything inherently wrong with this. However, I did say that J hat was away here, so that would be the positive, that would be the negative. So it violates that convention, but it's not, you would not get a wrong answer if you kept it as is, because it's equal to 0. All right, so now, got my 4 equations. What do I know? I know the masses. So I know mass. I know the angles. Weight I can find. Oh, well, let's go to the next step. Substitution phase. Do I have an independent equation for any of these variables?
Yes.
And what is that equation for an independent variable?
Weight equals mass times G.
And so if we stick that in, we have a weight into each of these equations, and so my 4 equations become the tension. The tension minus M, so AG sine theta A is equal to M subscript A times the acceleration. I have MAG cosine theta A minus y sub A is equal to 0. MBG sine theta B minus the tension is equal to MBA. And then YB minus MBG cosine theta B equals 0. I guess that S could stand for simplifying because we did multiply by 0. That simplified it some. Because there is no friction in this, the J hat equations are not going to have any impact in this. But we're now down to the solve. We're trying to find the acceleration. So I'm going to be using this and this equation. The accelerations are the same. The magnitudes are the same. And I'm just going to add the 2 equations together. Add the left-hand sides, add the